IEEE has got a beautiful definition of engineering which is applied to software engineering. Software engineering is application of systematic, disciplined, quantified approach to development, operation and maintenance of a software. Application of engineering to software is software engineering. So in this is very important to know that you need to follow the process in a systematic way, disciplined way. You have to do things in a repeated manner. There is no exception. You cannot do it in a dark way and quantified. Everything is measured. How much time is spent for development of a particular feature, how many defects are there, and what are the files which are to be maintained. And likewise, there are so many metrics, measurements that need to be taken care of. Software engineering can be also seen as a layered technology. You can define it as a layered technology where the bedrock, the bottom is the quality focus. You have to make a quality product. Quality can be defined as conformity to the requirements of the user. It can be seen satisfying the requirements or the expectations of the customer. And of course, the quality is brought up by a very good process model, a process which has got the steps to be done. The different phases are well defined, and these phases or the steps are using different techniques or methods, the way to do things, the task. There are multiple tasks are there, what to choose according to the process that you select. These methods are applied, and finally these methods are automated so that a human involvement is reduced and more output is produced. So we have automation as well as semi-automation tools that can be used for engineering a software. And we call this framework. When you look at this process, the entire process, it is falling into a set of activities that must have certain components or elements. Any activity, we can call it as framework activity or umbrella activities. Framework activities are the core activities. It will have certain tasks to be done and certain products to be done, produced. If you take requirement, you have to produce software requirement spec, SRS. If you are doing the design, you have to produce the design document. If you are doing the testing, you have to do the test plan. These are called work products. And all these are done with certain milestones and dates, target dates to achieve. By end of this first week, I complete my SRS, software requirement spec, specification, that's a work product. Milestones, by fourth week the architecture will be done. So finishing SRS first week is a milestone and deliverable is SRS. The fourth week architecture is done, the software architecture document is done, that's a deliverable. Fourth week is a milestone to achieve. So there are many milestones. When you travel from Yelagiri to Tirupattur, you have noticed on the side of the road milestones which shows the kilometers, how many kilometers are there to reach Tirupattur and so on. And similar concept, when you start the project, you start with the start date until the end date. It's a 90 days project. It is 120 days project. How do you go about? There are different milestones and deliverables which need to be tracked. These are described or fixed for every framework. And there are umbrella activities. There are activities which will be supporting these core activities, like we have quality assurance, then we have configuration management, system administration, risk management and so on, that we shall see briefly. So framework activities, all that we have, you can look at from the 5 major stages or phases. First one, communication, planning, modeling, construction and deployment. So these are the 5 major phases as given by Roger Pressman. The different authors present it in different ways. As this is your textbook, we shall keep to this. Communication. Any project that you want to do, it is based on communication between the developer, who is the engineer or the requirements engineer, with the customer, with all users, with the project manager, etc. So communication is very important. If a software engineer is not able to communicate, he cannot guarantee success to his work. And of course, planning is the project. How do you plan the resources, the time, the milestones, the deliverables, and so on. Modeling is the product that you perceive, visualize, because the software product, as the requirements are given, cannot be seen by the customer, and yet you have to prepare a model of the analysis based on requirements called analysis model and the design model. Analysis model, it puts all the requirements and this is what this product has to be, and the actual product that's going to be done is given in the design, the user interface, form design, the data design, the report design, the code design, the component design, and so on. That these two models are important: analysis model, design model. And based on these two, you get into construction, coding, and testing. And finally, it is deployment. So we can divide the entire software engineering process into 5 processes of communication, planning, modeling, construction, and deployment. As I said, there are multiple umbrella activities. Project management itself is very important. It starts right from the beginning of the project till the project is over. Then we have technical reviews which are done regularly, and quality assurance team has to work on quality right from the first day, and configuration management guy has to take care of all the files that is part of the product, and the preparation and the production of the work product, documentation, and looking into the reusability of the work done. Some of the components have been already developed for previous projects, how to make use of them, and measure the time, defects, and the work done, etc. And also risk management. There can be certain risk. A developer may leave the project, then there's going to be a problem. Technical risk can be there. You are unable to find a solution to a problem. So technology risk, customer risk, project risk, developer risk, schedule risk, and there can be multiple risks. All this will come under umbrella activities. So we put the entire process framework into core activities, framework activities, and umbrella activities. So let's how you begin a project. There is a project which is given to you in your textbook known as Safe Home. How we can make your home safe from the burglars who can enter, the thieves who can enter, and making sure your air conditioning or the heat system or your pumping system are in place. It's a beautiful project explained, which with a lot of devices, the software, with a mobile app, and so on. It's given in your textbook, and that's the thing is to make home safe. Now to this safe home application, you can correct some defects. There's a need to make it better. You have a legacy system. You are doing certain things like computerization of the marks in the thing. You type and everything is done mechanically. That needs to be brought to an automated system. So you may already have a software which you want to make it better. You want to extend the features, and that's also a new project. Finally, a new idea has come, a new problem for which you want to give a product or a service or a system. So from any of these aspects, correcting an existing application or converting a legacy system to a new environment or extending the functions or features of an existing application or the need to create a new product can be the starting base for a software engineering project. Of course, the flow is different. You have different types of flows that we have. Process that I said, a linear flow means one by one you do communication, planning, modeling, then we have construction, and you do in a linear way one by one. Normally it doesn't happen like that. The communication and planning can go through a cycle, and the modeling itself through multiple cycles, and from construction you can come back to communication, you can go on. So there is a kind of a iterative process. Iterative means repeatedly you do, and that is the second way in which the process flow. And also there is another, the entire process of development, right from communication, planning, modeling, construction and deployment, will go through evolution. One by one, an increment can be done. Step by step you make the software, you have version 1, version 2, version 3. Windows has got so many versions today, right? So that is the way in which also the software is developed. And fourth, it can be a parallel while communication is taking place, planning, both together, modeling, then you come for construction. So the way you organize these 5 important stages or phases or the processes of the bigger software engineering process depends on the context of the problem. The people who are involved, it can change.